Hi there. So for the second half of Chapter 2, Section 4, we're going to be looking at the mathematics related to chemical equations. And basically what that is the law of conservation of mass. So you want to write this down in your notes. The law of conservation of mass says that mass is never created nor destroyed in any chemical or physical change. If we start with 10 grams of water as a liquid and we boil it, it will make 10 grams of gaseous water, of water vapor. And same way, if I take 5 grams of one substance and react it with 5 grams of another substance, the product should weigh then 10 grams. So we have a formula that goes along with this. And we haven't used formulas too much this year so far, but we will. And so this first formula, it says that the mass of the reactants, that's what that subscript means, must be equal to the mass of the products in a chemical reaction. So we're going to apply that formula to two practice problems in just a moment. But before we move on to those practice problems, I wanted to talk a little bit more about how we're going to be solving mathematical problems in chemistry. And you're going to hear me say this all the time, that we need to circle the do and underline the clue. What does that mean? So circle the do means when I read a question, a mathematical question in chemistry, I look for what the question is asking me to find. That's the do. That's what I need to do. Underline the clue says when I go through and do that, I underline the pieces of data or information that I am then going to need to solve that problem. Circle the do, underline the clue. And then again, you'll see this capital F and then the number sign and then A. And those are the steps for when you're using a formula, how to problem solve. So the F obviously stands for writing out the formula. Every single time you're doing a problem with the law of conservation of mass, you should write out the formula. Therefore, by the time the test comes around, you already know what the answer or what the formula should be. It's already in your brain. Then the number sign is just about substituting in the numbers, the clues from your problem, and then solving. Some problems will just be a multiplication problem, like with dimensional analysis, or it could be more algebra related. And then A means get your answer. And the prompt says report your answer to the correct number of significant figures and units. Well, significant figures is something that we will learn about in Chapter 3, so don't worry about in these two problems. But units are really important in chemistry. You want to make sure that every number that you write in this class, almost exclusively, will have a unit with it. So in math class, you might say 2 times 3 is 6. In chemistry class, it would be 3 meters times 2 meters equals 6 meters squared. So we're always going to be using units. So let's take those concepts and then apply them to these two problems. A 10-gram sample of magnesium reacts with oxygen to form 16.6 grams of magnesium oxide. How many grams of oxygen reacted? So read through the problem once. Then read through it again with the circle the do and underline the clue. So a 10-gram sample of magnesium, that seems like that's a clue, reacts with oxygen to form 16.6 grams of magnesium oxide. That's another clue. And then how many grams of oxygen reacted? That's the do. That's what I need to do. So I circle that. Now I write the formula. The formula is simply the mass of the reactants. I'm just going to abbreviate that with a lowercase r is equal to the mass of the products. Read the question again. What are the reactants? Well, that would be the mass of the magnesium and the mass of the oxygen. Oxygen symbol is O2. Magnesium symbol is Mg. If you don't know that from a previous class, you can always just write out the whole word, okay? Or look at a periodic table. The mass of the reactants is equal to the mass of the products. And in the question, I can see that the mass of the product is magnesium, or is the chemical magnesium oxide. Again, you won't know the formula for that quite yet. Just write out the words magnesium oxide, no problem. Now, substitute in the numbers. The mass of the magnesium is 10.0 grams. The mass of the oxygen is what I'm trying to find. So I'm just leaving that in there as the variable that I don't know. The mass of the magnesium oxide is 16.6 grams. And now I will use algebra to subtract 10.0 grams from both sides, and I wind up with that the mass of the oxygen is equal to 6.6 grams. In terms of actually doing the calculation, use a calculator. You will get to use a calculator on everything in this class. Nothing is ever non-calculator. And remember to put the unit of grams at the end. When you're subtracting grams from grams, the answer is grams. There's another problem here, and if you feel confident that you can solve this problem on your own, pause the recording and give it a try. And then click it back on and see if you did solve it correctly. If you're still learning, that's great. Just follow along with me now. When 14.3 grams of ammonia, NH3, decomposes, 11.7 grams of nitrogen is recovered. How many grams of hydrogen must have also been released? So this is a decomposition reaction where we start with the chemical ammonia and it breaks down into nitrogen and hydrogen, the two elements that make it up. So 14.3 grams of ammonia, that's one of my clues, decomposes to produce 11.7 grams of nitrogen. That's another clue. How many grams of hydrogen? That's my do. That's what I need to solve for. Okay, write down the formula. The mass of the reactants must be equal to the mass of the products. What is the mass of the reactants? Well, that's the mass of the ammonia, NH3. That must be equal to the mass of the products. One is nitrogen gas, that's N2, and the other one is hydrogen gas, which is H2. Substitute in the numbers. The mass of the ammonia is 14.3 grams. The mass of the nitrogen is 11.7 grams. And the mass of the hydrogen is what I'm trying to solve for. Now use algebra to isolate the mass of the hydrogen on one side. So opposite operations, since 11.7 is added to the hydrogen, I'm going to subtract 11.7 grams from each side. My answer, I'll write it over here. 2.6 grams of hydrogen gas must be left over. And that's my answer. Matter is what this whole chapter is about. And there's 3 different ways that you can organize matter. So the first box here would be organizing by its state. So in the 3 boxes below, what are the 3 states of matter? The next one here is purity. And I put a line through it because the first thing that happens to these, let me just make it pretty, is that breaks up into 2 more boxes, and then those boxes break up into substances 1, 2, 3, and 4. And there's clues down here to help you with those. And finally, you have changes. And so go back through your notes, look at the 2 different types of changes that we discussed, and give 3 examples of each. So we'll compare our completed graphic organizer the next time we are all together.